Good morning, dear students. How are you all? So, dear students, this is the first video of class 10 for the week, and in this we will talk about that the different types of chemical which is formed by the sodium chloride. As you know that sodium chloride means NaCl, okay na, and we will obtain the different types of chemical from this NaCl. Okay, dear student. So this is our topic, and you can see here that first chemical we can obtain from the sodium chloride, and that one is sodium hydroxide. Sodium hydroxide can called as soda lime or NaOH. Okay na, NaOH means sodium hydroxide, and in the common name we can also call it as a soda lime. Sodium hydroxide is the example of strong alkali. It is commonly known as caustic soda. Okay na, dear student. So this one was the theory about the sodium hydroxide, soda lime. Now we will actually produce the soda lime NaOH by the chloralkali process. Okay na, chloralkali process. What is chloralkali process? You have to understand, and why the name chloralkali is there, you will understand after the procedure, after the preparation. Okay na, dear student. So let's see the another slide. In this first slide you have understood that sodium hydroxide, and here you can see that the example, it is commonly known as caustic soda, and it can be prepared, it can be manufactured by a chloralkali process. Now here you can see chloralkali process. Dear student, you can see in this process the chlorine is obtained at anode and hydrogen gas is produced on cathode along with NaOH. How the procedure would be there, I will show you what is the meaning of that one. Cathode and anode, you can see this is the chemical reaction. Here I have taken NaCl plus H2O, and together NaCl plus H2O, NaCl in a water, in water it can called as brine. It can called as brine, B-R-I-N-E, B-R-I-N-E. Okay na. If one solution is there which is prepared in water of common salt which is dissolved in water, so that is known as brine. Okay na. So you should see this chemical reaction, and here you can see this one is a strong alkali and this one is chlorine, and with the evolution of hydrogen gas. Okay na, dear student. Now you can see here in this process it is written chlorine and hydrogen gas combined. Where is this one? In this process it is written, in this process chlorine and hydrogen combine. So you can see this chlorine and hydrogen will combine, can combine, okay, and it will form HCl, hydrogen chloride. Hydrogen chloride is gas also in the liquid form. In the laboratory it is also available. Okay na. So you can see this one is HCl gas, but I will not say to make this HCl. Why? Because this is unstable. HCl is unstable. Okay na. Again and again it will break down into hydrogen and chlorine. So it is not good to write chlorine and hydrogen. Okay na. So we have written that one. Now I will show you the procedure, how the procedure would be there. Okay, and you can see this one here. I will tell you how the procedure, how, oh sorry, by writing the diagram, by making the diagram I will show you. So here I have taken one of the beaker. This one is not going to be bigger. Here I will take one beaker or some container. Okay, you will take, and here you can take some electrode. Okay na, electrode. That electrode which is connected with the source of battery, negative terminal, positive terminal, and here it is connected with other electrode. Here I have taken that brine solution, you know na, NaCl solid plus H2O liquid. Okay na, dear student. So what you can see, this one is brine, and after passing the electricity through this one, that NaCl can break into ions. Okay na. Now I am telling you, as you have understood this one negative, and this one is made up of electrode. Okay na, cathode and anode, cathode and anode. So this NaCl, after passing the electricity through this one, NaCl and H2O will break down into this one, Na plus Cl minus, and this H2O will break down into H plus OH minus. In the previous class, you also we have in the previous chapter, in this we have also discussed that one. Okay na, NaCl, how it will break down. Okay na, so you can see this. Okay, so here Na plus Cl negative, H plus OH negative. Lots of student make do in a hurry that they actually complete the reaction like this one, Na plus OH, and they write HCl. Okay, as I have told na, that why you cannot form HCl. Okay, what is the product? It will form NaOH. After the combination of this one, it will form NaOH. So you have understood. I am writing freshly this one, NaCl solid plus H2O liquid. What it will break down into? It will break down into Na plus Cl negative, and this will break down into H plus. Can I write it here? H plus and OH minus. Okay na, OH minus. So Na plus and OH negative, what it will give? It will give NaOH. Okay na, and instead of forming HCl, we have to form chlorine, Cl2 and H2. Why we are not forming HCl? If I have to form HCl, then why I have taken that electrode? What is the work of cathode and anode? Okay na, why I have taken in that picture cathode and anode? So I mean to say that one, that if I have taken that picture, this I have taken one of the electrode here, one of the electrode here, one of the cathode, one of the anode, and I have connected this one with the this circuit. That means if in the solution H plus is there, Cl minus is there, so Cl negative will go, okay, and discharge their ions. H plus will go, and yes, H plus will go and also discharge their charges. So that's why they H plus will actually go and discharge to form hydrogen. Okay na, H plus after going this at the cathode, it will discharge, okay, Cl, it will also discharge, it will form chlorine. Okay na, H in a solution, if NaCl is there and H2O is there, that means it is not possible that only one water molecule is there. Thousands, lakhs, crores of water molecules are there. So if I will take only two atoms of hydrogen, so two atoms of hydrogen ions will discharge to give two hydrogen. So one hydrogen, what it will give? H2. You have understood how it has given H2. Now Cl negative and Cl, one more Cl you can take. Okay na, so one more Cl and Cl, what it will give? It will give Cl2. So you have understood how it has formed. It is the problem, of the ions, they want to discharge and they have to combine anyhow to form their stable state. H plus is not the stable state, hydrogen gas is the stable state. H plus will go and discharge on the cathode or electrode, and then after we can say that it is the it will form the stable state. That one is the hydrogen and chlorine gas. Okay, dear student, so this is the thing that I have given you in the chemical reaction. Okay, dear student, now you can see that the reaction, again you can see the reaction. Okay, here now some of the properties of sodium hydroxide. It is a white deliquescent compound. You will see that it is available in the pellet form in the laboratory, just like this one, white. It is a white one. Okay, and it is highly soluble in water. If you will put this into the beaker which is having water over there, so that one will actually highly soluble. Okay na, and as it is a, okay, so as it is a ionic compound, sodium hydroxide, so what it will form? Ionic compound, you know na, Na plus OH minus. So what it will form? Oh, sorry, that's why it has a permanent bond, ionic bond. Ionic bond is the strongest bond, so it has high melting and boiling point, and it is corrosive in nature, you know, somewhat. It can damage your skin also. It is the conductor of electricity. Yes, this one is a basic one, and basic also dissociate into ions, and we can say that one is conducts electricity in aqueous solution, and it can emulsify the fats and oils in water. Okay now, so emulsify means it can create that stage by which that both can mix, water and oil can mix in equal proportions. So that is the meaning of that. Okay, so properties of sodium hydroxide we have done. Okay now dear students, so we will meet in the second video. Thank you. Take care of yourself. Thank you.